it's like, you're making one small error in the essay and this teacher strikes off everything and gives 0. So what happens is when one positive is written as negative, the whole text goes into the negative classification. So it could be a tweet, it could be a Facebook status, it could be a review on a product. Now you have written a review on the product. Now let me be a little more specific. I'm using a taxi. Okay, your Ola taxi which brought me here today. Now I write a statement. The taxi service is very bad, but the driver is very good. See, I have one positive statement, one negative statement. When I am focusing only on the positive statement, the taxi service is bad, I am also undermining the driver's capability. So the entire text goes into the negative comment. And recently I was having a talk with one of the Ola drivers wherein he was telling me that the Ola app, what happens is when you are trying to rebook, once I have booked and you have used Ola, when I am trying to next time book it, it will first go to the app where you have to rate the previous driver. Okay, suppose you have used the Ola 15 days back, you don't even remember who the driver was, but till you rate the driver, it will not allow you to book. So what you do, you just press some 3 or 4, you don't even know what it is. So the driver's rating will go down. So he was telling me the other day on the way back that Ola people are doing this just because of one particular rating, the rating goes down and they are not giving any incentives to the drivers. So this is an example of where you are trying to use one particular measure and trying to classify. So one rating of negative is actually not the driver's rating. I could have many reasons for rating him like that. And if he surveys 50 customers and one customer gives less, mean will bring down. See, all are 25, because of my age, everybody's mean is going up. Something like that happens. So the false positive and false negative definitely is a very tricky business here. You have to keep track, especially in text analytics. Data is fine. Text analytics, it's very tricky.
I think the question was how you get the probability of the word being positive. Like you said, like probability of food being positive or negative or neutral is equal, right? That's 33%. So how do you get that probability for all the words?
Okay, now that probability is got by using the corpus. See, as I said, if I'm using a restaurants or a chefs or a nutritionist corpus, food is always having a positive connotation, right? When I talk about a doctor or a hospital's corpus, what happens is food is something negative there, because food is causing the disease. So it depends on the corpus. So when I talk about food, I was explaining, food can be used as positive. I love food, or food is nutrition. Food makes you fat, negative. Everyone needs food, neutral. So there we assume equal probabilities. We assume.
How do we deal with it when we are analyzing tweets? It could be any context.
Yes, generally, see, that's what happens is the best way to do is empirically, you try to find out the number of times food occurs positively, divided by the total number of times food occurs.
But then isn't the corpus changing continuously? I build a model based on, say, I take 1,000 tweets, or for a week I take all the tweets and I build a model. But the model is ever changing.
Yes, it's this is a dynamic model. In fact, your question has made me tell you another concept, which is wherein we link the probabilities. Like you said, now this week's tweets I take. Now next week it has changed. It's a dynamic model, it's not a static model. Every week it is changing. So what is the probability of the food being positive in the next week's tweet also? This is only by assumption, because I don't know whether it's positive or negative till the week is over. Now say tomorrow week is starting. So what I assume, in this week the same trend as last week's tweets will follow, will be there. It may change also. Now for example, this week the Prime Minister has done something very good. So all the tweets of the Prime Minister will be positive, majority. Probability of the tweet being positive is more. Now I assume that the coming week also the same sentiment continues and it will still remain positive. Now here one example I could give. It's a dynamic situation wherein we cannot have a probability estimate and use it always. It has to be updated constantly. Now suppose I sell a product. Okay. Now the product is defective. The customer comes to me with the complaint. Now I have to assuage his feelings. I have to say, okay, fine, we are sorry. What I do, I not only change the product, I also say, okay, you get some 100 rupees off or something like that, or some 1 week of free talk time, you get something like that, I give. Now after 1 week, I have to find out whether his anger has reduced. He has got his product repaired, he has got 100 rupees talk time. Now what is his sentiment about me? It may differ. Not all people will be happy getting 100 rupee talk time. Some people may be also be angry that you made me waste, run around like this. So here it's a dynamic model. See, when we are dealing with people, the sentiment analysis has ever changing values. It's a dynamic real-time problem. There cannot be an estimate, at least not a good estimate of the positives and negatives. There is no way we can have it. It's not like, our basic sciences. Physics, chemistry, we know E is equal to mc square. For the past so many years it's like that, from so many years it will be like that. But when you are talking about real life data and people, you cannot have. It is a very evolving.
Statistics, like what are the things which will help me deal with this sort of
calculating probabilities again and again. Now for example, like food. How many times has food been used in the positive sense? So suppose, now let me say, see, I'll give you a small example here. A child is going to be born. Our estimation, our understanding is probability of it being a boy is equal to probability of it being a girl is equal to half. This is our starting point. If we don't have this hypothesis, we cannot do any estimation. But in real life what happens, in many families you see only girls, in many families you see only boys. That means it's not really correct. Then what I do, I take some empirical data. I take 1 lakh families, and in that I find that 55,000 are girls. So it is not actually 1 by 2, it is 55,000 divided by 1 lakh, higher than 1 by 2. So here I revise my probability. So what we do here is, we have a hypothesis saying that okay, the trend of this week's tweets will be the same as the previous weeks. Then either we reject it or we accept it, because there is no way we can find out the correct answer before the week is over. You only have to work with assumptions and you have to work with the data counting. There is no other way. Keep updating it. That is why updated bills. What is the probability that today also food will be good, given that yesterday it was good? We have a formula for that. It's a product term. It's called the chain rule of probability. I will show you the application.
Can we have a software, something that you talk about, like there's a suicidal note, and can we have something like that in which a psychiatrist or a lay person also throws a question to the patient or someone who is suspicious of having something? So can we have a software in which his speech is converted to a text or something like a computer itself can have kind of a report, yeah, this is susceptible to some kind of a disorder or a suicidal tendency?
Yes, definitely yes. See, what happens is, all these suicide helplines, right now they are all manned